Hello guys, welcome back to the channel again. Today we will solve the last and the 30th question of June Leetcode challenge. So our question is word search. Now what we have to do is we have given a board in which we have some letters and we have given an array of strings and we have to find that strings in this board. Now what is our condition? That the word letters should be adjacent to each other. In this case, if suppose we have to find out OATH, this OATH we found here using this O here, A here, T here and H here. So these are adjacent. Now what is the condition for adjacent? The element or the letter should be either left, either right, either top or bottom. So they can be on any side of the element but can't on the diagonal side. It can't be on this K, it cannot be this I, it cannot be A, it cannot be O if we are on T. So we have only 4 elements to check at every index. So using this we have to find out our word. Suppose if we want to find out for eat, how we can find E here, A here, T here. So we found eat. So this is our solution, and at the end we have to return the strings which we found in the board. So what we have to do, we have given a board a list of words. We have to find the words in the board who are adjacent to each other. Means the words can't be adjacent to each other or maybe adjacent to each other. And one more condition we have to follow is that the word which we used once in a string or once in a word, we can't use that letter again. Suppose we have 3A, AAA as a string, we have a string AAA, so we can't use single A 3 times. There should be continuous 3A. In this example it is here first A, second A and third A. So if there was one more string AAA, this would be a valid string for this board. So this is the question explanation. Now I will explain the solution, that how we will solve this question. Now for understanding the question, we will take this as example. In this is a board and these 4 are the words. So we have to try to find out these 4 words in this board. So first we will try manually that what all words we will find out in this board. So first is OATH. So we found O, then A, then T, then H. Nice. Now we will try to find out this PAA. P. So we will try to find out first P. So P is not there in the whole board. So we will reject this second word. After that we will try to find out eat. So we go to here E and we will try to find out A. So A is not adjacent to any, sorry, A is not adjacent to E. So we will drop this E also. So we will try to find out the second E. So we have this E. Now we'll try to find out A. So we got A. Now we'll try to find out T. So we got T. So our second word is EATE. Now we'll try to find out for RAIN rain. So R, A, we does not found any A adjacent to R. So we'll drop this rain also. So now we found 2 strings. First is oath and second is eat. So our answer will be eat and oath. Now as soon as we encounter this question, first thing which came in our mind is backtracking. That using backtracking we can easily find out if we have this O, we can go to A, T, E, and using backtracking we can easily find out. And you are 100% correct that in this question backtracking will be used. So till now we all understand that we have to use backtracking in the question. So after that the question comes in our mind that will backtracking will be sufficient for this question? So the answer is no. Why backtracking is not sufficient? Because if you want to search for OAT, and any other thing also come with OAT, and then after H there are some more numbers. So at that condition this becomes false. That means this condition or the iterations will be higher. Suppose a string comes A, B, C, D, something like this, and some any other string also comes with same prefix till this, and then some more values came. So for that our work increases, because for ABC we have to start reversing in this also, and we have to start reversing from ABC from the starting in this also. So to reduce this part we will use a data structure known as Trie. Now first of all we will discuss the Trie data structure, that what is this data structure, and then we will try to solve this question properly. Now before going to the explanation part, I'll first give you an example of that data structure which is used by many of our running websites. For that we will take the example of Google. In Google, if you search Trie, the suggestion which is coming in front of this is the example of Trie data structure. Now how this is happening and all this, it is the part of data science, so we will not use that part. So in this the prefix is same and the other part is different. So for that we will use this Trie data structure. So if you want to understand this more correctly, I'll give you the link of Geeks for Geeks. You can understand more properly for there, because in this lecture I'll make you understand a bit about Trie, which is sufficient for solving this question, and for any other question it will be not sufficient, because I'm just going to explain the insertion only, because in this we does not require to delete any node. So in this we will not discuss about deletion of a node in Trie data structure. So now first of all we will try to elaborate that what is Trie data structure and how it stores the value. So what it does is it stores a root node. This will be a root node, and it have 26 nodes. So it has 26 nodes. At every node there is some address. It must be there. Now suppose we found O. So O will be inserted, suppose here at this first node, and then A came. So A will be inserted further in this node. Then T came, so T will be further inserted in this node. Now suppose again the this word gets over and again O came. So this will traverse this only, this node. Then it will go and check that this A is there or not. If A is there in the next string also, then it will go further. Now it will check that the next element is T or not. So if the element is T only, then it will further proceed. And if the node till now we found is different, suppose we have one more letter in which we have given O, A, B. So here we have O, here we have A. So we will insert one more node here, B. So this is how Trie will help us to skip these both iteration in backtracking. So first of all we will try to find out that in Trie how we will insert and how it will help in our question. So this is the structure which we are going to use for our Trie data structure. In this int v represents that the number or the word gets over or not. Suppose if we are on H, then this will we will be initialized with 1, which will symbolize that the word is complete. And what this node will do, I'll explain you when I'll explain the data structure. So now we'll discuss the data structure. So first of all, as soon as we enters in the loop and start iterating over the values, so first we will look at the values, that how we will insert all the values in the Trie data structure. So first of all, this root will be initialized. So root will be empty initially, so it will have 26 childs as a next. So how it will point. Suppose O came, so for this O we will create one more node in the next, and we will store O here. So O will be stored here. After that, one more node will be created in which this will also point 26 nodes. After every iteration or after every node make there will be 26 nodes. So after this also one more node will be created. So at that A will be there. After that this T came. So for that also we will store this T. Now H came. So for H also we will store here only. So this is our first strings insertion. So suppose let's consider one more example. It will be O A B C. Suppose this is our example. So this is our next word which we want to insert in this Trie data structure. So how we will insert? So our next value, what it will be? It will be O. So we'll try to first find out that this O is there in this 26 numbers or not. If there it is there in this number or not. If it is there, then we will traverse this O only. So we will go on this node. So now we will check that what is our next value. So it is A. So we will check that this value is A or not. So if this value is A or not. So if this value is A, then what we will do? We will go further. Now we will again check the condition, the value B. So this is B or not. So in this is not B. So what we will do? We will create one more array. One more instance of this A, and we will initialize this with B. After this C came. So we will initialize one more C. So this is the explanation that how we will create this trie node. So after that what we will do? We will insert that the coding part comes, that how we will insert using the coding. So we'll look at that part. So this is the code for the insertion part. So first of all, here I have created the root node. So after this execution, one root node will be created. Now after that we will go for this loop in which every word will be picked from these words, and after that as soon as any word picks, we will initialize one more pointer which will point this root. Now what we will check? The first condition, that this character C. Now after the initialization of pointer, this words every character will be pointed. So first of all this O came. So how this O will be pointed? So first of all we will check that we have this O in this previous root or not. So how we will check? We will first convert the character into its significant ASCII value. So in this it is not directly converting into ASCII, it is converting to its representation. In this what I am doing, I am considering A equals to 0, B equals to 1 till Z. We have considered all the values till 26. So all the values will be there. For A we will assign 0, for B we will assign 1, for C we will assign 2, so on till Z as 26. Now what will happen? So we have this value. So we got O. So first of all what we will check? We will reduce this O to its number. So O, what it will be? So O will be 15. So what we will do? We will check that next 15 index, means next 15th index is filled or not. So suppose O is pointing the 15th node. So if it is filled, means if it is not null. So initially we will initialize all the values of this next by null. So we will check that the value is null or not. If the value is not null, so we will take this as a root. We will consider this as a root now, because we found this O here. Then if we don't found, suppose if we do not found this 15, so we will create, or it is previously created, so we will initialize one more variable. One more, this next will be initialized now. So in this case we does not found, so we will initialize it with 15. So after that, what will happen? At this, we will create one more tree, and in this tree, it will be pointing all the values. So similarly, what it will point, now we'll consider this as a root, and all the values will be pointed, and then again the loop will be iterated. So we will go to A. So we will check that 0th index. So 0th index is fulfilled or not till now. So it is not fulfilled. So we will create one more node. So now we'll go for T. So we'll initialize T. Then we will go for H. So till now it does not found any of the values. So we will make a data structure new only. So after that, P came. So we'll check P. So P is there in this all nodes or not. If it is not, sorry, we will check that Pth index is previously initialized or not. If it is initialized previously, then we will traverse that same node only. So in this case, it is not initialized, so we will initialize one more. After that, E came, so E will be again initialized. So this is the creation of three data structure. So this data structure will be created after the iteration of all the values. Now as soon as you came on the edge, so this loop will be terminated, and the edge v index, so this v will be initialized with 1. So this will be initialized with 1. So suppose one more same character came, then this will be initialized with 2. Now one more same character will become, so this will be initialized with 3. So in this question, we does not require to increment again and again, because in the question it is given that the words will be different. So it does not need to this increment. We can directly make it equals to 1. So this is until now what we have done. We have understood the Trie data structure and we have inserted the nodes into it. Now we will go for the fetching part, that how using this, how we will do the backtracking part. So now we'll understand the backtracking part. So after the insertion of every node into the Trie data structure, this will look like this. So this will be the root and this will point all the values. So now what we'll check, we will go for the board part. So we will start iterating over these values, this O, A, N, EAT, and then all the values. So first we will encounter this O. So we will check that this O exists in this any node or not. If this exists, then we will go for backtracking part of this whole. If it does not exist, then we will go for next node. Suppose A, then A is also not there, B is also not there. So suppose if we found O, so we are on here this O. So we will insert this into a new string car character, in which we will store this O initially. Then we will go for backtracking part of this. Then we will check that in these two adjacent nodes, this A is there or not. So A is there, so we'll append A, and we will go same with this also. So till now this will be considered as root, and we will try to find out this T. So we have three possible paths, so we'll try to find T. So T we found, so T will be added here. After that we will go for this H part. So this H came and H will also be inserted. So we found this oath. So similarly we will do for every node, and then we will insert after every node. So if we go till H, if we are all H, we will check that V is here 1 or not. If V is 1, then we will append this value, this character, into our answer, else we will go further. So this is the explanation part, in which I have explained that how we will create this tree, and then how we will search in using backtracking. Now many of you must not understand the backtracking part, so for that I'll first explain the code, then we will submit the solution. So now we will check that. So this is the code for the starting of backtracking, in which we are checking that the nodes are there in the try or not. If it is there, then we will call this function in which current will be our value, in which first index will be initialized with this particular value. So how we will check the boards? So we will check with the help of this I and j, which will go from here, then this first line, then this second line will be iterated, then this third line will be iterated, now this fourth line will be iterated. So at any point, if we found the value, then we will call the backtracking function, in which I have done the backtracking part, and then we will iterate over all the values of this root or this trie. So now we will look at our main backtracking part, that what we have done. So this is the main code of backtracking which we will use. So first of all, I have taken the x and y, which will point the current index of the board on which we are currently iterating. Suppose on 0, 0, so this I, x and y will point the current indexes. So after that, I have taken the board also in the function, and the node which is currently we are on, the node of trie data structure. After that, the answer, in which answer will be stored, and the string current, in which our current word is going. So first of all, I'll initialize the temp with the board. Means suppose we are on this 0, 0, then what we'll do, we will replace this by hash, such that this value can't occur again. Means we can't use the value again, so we will prevent this thing using this hash. So we'll convert the character by hash. So after that, I have initialized node x, the next of temp. Means in the Trie data structure, what we have done, here we have suppose O, here we have A. So I have traversed this O, so now our node will point this A. So we are now this on A. So now what will happen? We will check that this node V is greater than 0 or not. So now we are checking that we are on the end of some letter or not. If we are on the end of some letter, then this letter will be pushed back into the answer, and then y will be v will be decrementing. Now why this is happening? This is happening for the character part, that if we found the character, then this is happening, that the character will be pushed back into the answer, and then at the end the answer will be returned in the solution. So this is the part in which first I am initializing temp, then initializing the board. And why I am initializing temp, that at the end I'll again initialize this hashed by the temp. I have initialized this trie. Now what this trie will do, so this trie is doing the main part of checking the 4 nodes. So they suppose we are on 0, 0, then if we add these 4 values, so these 4 combinations are only there on which we can go. Suppose we are on 0, 0, then we can go on 0, 1 only, 1, 0, 0, -1, or -1, 0. So these 4 available nodes are there for every condition. After that, this 4 and this will be iterated on all these values. So first of all, as soon as we came into the code, or as soon as we entered into the loop, this x will be incremented by the value. Suppose 0, 1 is there, so this will be added by 0 and this will be added by 1. So the new value will be 0, 1. So now why we are doing this thing? We are checking the node. Suppose we are on T, so we have 4 possible nodes, this, and this. So for that we are doing this stuff. So till now what we have done, we have came on the node. Now we have the path that where we have to go. So x and y we have. Now as soon as we have updated x and y, we will check that x can't be less than 0, x can't be greater than the size of board, y can't be less than 0, y can't be greater than the board size. So these 4 conditions we have checked, and the new node can't be equals to hash, means which we have previously visited. Now next thing what we will check, that the boards next means the current index on which we are is equals to this or not, means the next which we are expecting. Suppose we are on A, then we will try, then we have T currently, so we are on T. So now we'll check that any of this node is, so any of this node is T or not. If the node is T, then we will first push back that into the current. So now current will be initialized with O, A and T, and this will be again called, the backtracking part will be again called, and now this will be treated as the root, and these all values will be now checked. Now if we found some values, then we will do the backtracking again and again. If we suppose we are on this T only and we does not found H, now again we will come to the T and we will remove this T. Now we are on A. So what we will do, first of all I will do for the next searching. So I'll go for this A. Suppose if we found T here also, then we will check the next values. So this is done by the backtracking part. So this is the standard backtracking part in which we are checking that backtracking with the help of these nodes next. So this code, this line is important. Which line? This line. This main line is important, in which I am checking that the value or the next node, this part, this which I have not highlighted, the between of these square, this is the main part in which I am checking the next value is current or not, means the next value of the node on which we are is the board's current value or not. If it is not, then we will not go for the insertion part, or sorry, the backtracking part again. So we will again start the loop with next value. So next value will be checked again and again, and at the end, if we found this thing, we will push back into the answer, and at the end we will return the answer. So this is the code for my backtracking part. So now we will see the combined code and then we will submit our solution. So first of all, this is our main code. From here it will go to the backtracking part again. So here I have got the board and the word as input. Now I have first checked that if any of this is empty, then we will return the emptiest thing. Now next thing, what we have created, the root we have created. After that, this is the coding of the trie node in which I have created the trie data structure. After that, I have initialized the answer. I have initialized and m as the board size. After that, what I have done, I have iterated all the values of this root, the board, and then I've checked that any of the value match with the board, roots or not. If it match, then I have called the backtracking. And in the backtracking, what I have done in the backtracking, first I have initialized this stamp and then hash. This is the code which we have discussed for the backtracking. And in this above part, I have initialized this trie, which will be the data structure in this trie node. So this is the solution for the 30th question of June Leetcode challenge. And if I submit the solution, I got correct answer. Thank you guys. For more such content, like, share, comment, and don't forget to subscribe.